Hey guys, you're watching Python tutorials on my YouTube channel, Python for Microscopists. I've covered quite a few deep learning topics, including the one from last tutorial number 128, where we have done data augmentation for convolutional neural networks, especially the malarial cell binary classification problem. Now, I started to realize that there are certain aspects of these deep learning algorithms that, or the deep learning process, that are very important, but I haven't talked much about it. So I'm going to take the next 2-3 tutorials to cover these topics. So starting with this one, where I'm going to talk about callbacks, and checkpoints and early stopping are a couple of callbacks. And a callback is basically an object that can perform certain actions. The action can be, hey, go ahead and stop the training because I think we have reached the enough validation accuracy. Yeah, that's just an example. There can be many callbacks. So let's jump into the code so I can talk a bit more about it, okay? First, I can zoom out of this so you can see exactly what we had from the last time, okay? So we used data generator and then defined the model and generated images based on what we have defined in our data gen, okay? Right there. And then all these generated images went into our model.fit, yeah, and we did fit a model and we saved it. So let me zoom in to explain this a bit more. I'm not going to go through every line of the code. I've already done that in the last tutorial, okay? So again, looking at the structure again, so this is our model, okay? Just a couple of convolutional layers, and then we are compiling it using binary cross entropy. Again, this is a binary problem in this case, and metrics that we are tracking is accuracy. And then I defined a batch size of 16 because there are various places where I use batch size, so I kind of parameterized it up there. And I defined my training data generator as rescaling, rotation, shear, and zoom. Okay, so this is defining how my data gen is going to generate all these augmented images. And my validation data gen, I'm not generating any new or augmenting the data set, I'm just rescaling it, yeah? And train generator and validation generator both are coming from the cell images folder. I mean, the training data set is cell images folder and cell validation folder. In other words, the cell images, this folder is for train generator, and the validation folder, which has a very similar structure, is for the validation. Okay. And now let's get to the point here. I added a checkpoint and I didn't talk much about it. So this checkpoint, let me delete this line. Initially, I was saving everything into single file. Okay. So what this checkpoint is actually doing, or a callback, you can let me rename this as callbacks. Okay. So I'm adding callbacks. Again, what's a callback? It's an object that can perform certain actions. If you look at our model.fit, you see down here callbacks. Where is that callback coming from? In this example, it's coming from what I called a callback list. Yeah, the list has only one entry here, checkpoint, which is the model checkpoint. Okay, again, I don't want to confuse you, so let's go one by one. Let me increase the room here. Okay, so let's start by talking about model checkpoint, which is one of the many callbacks, and I'm going to talk only about 3 callbacks, and I'll leave the rest for you to explore. So the 3 callbacks I'm going to talk about is model checkpoint, early stopping, and something called CSV logger, which I think you'll appreciate. So let's start with model checkpoint. This callback saves a model at certain interval. Okay, so here I gave a file path and I said, okay, in a folder called saved models, okay, in a folder called saved models. Right now I have 3. Let me delete everything. Okay, here, okay, save all, the models under this file name. The file name basically is weights improvement, and then whatever that epoch number is. If the epoch number is 5, that would be 5, and whatever the validation accuracy value is, and .hdf5. Okay, so that's the file path. And inside this checkpoint or model checkpoint, I'm given the file path, okay, so that it can save it under that name. And when is it saving? You can save it after every epoch if you want, but in this case, I'm saying, okay, monitor the validation accuracy, and whenever the accuracy improves, go ahead and save that. Okay, I said save best only equals to true. That's what that is. And I put mode equals to maximum because this is, we are monitoring validation accuracy. If you're monitoring loss, we are trying to minimize the loss, right? Then the mode would be min, M-I-N. Okay, so that's what this checkpoint actually does. So let's go ahead and run this for 5 epochs and see how the output looks like. Let's go ahead and run this code. Okay, so our 5 epochs are done. At the end of it, it's going to save everything into this file. But if I go to our saved models, you see how it saved these 2 models? And it did not save model after every epoch, because here you see validation accuracy improved, saving the model to saved models. At some places, validation accuracy did not improve, right? If you look here, it did not improve. Validation accuracy did not improve. It only saves it when it gets improved. Okay, so that's the first callback. Now let's actually add a couple more. Let's actually add another callback. And this time, let's add an early stopping. Again, I'm including this early stopping. Did I open this page here? Yeah, I think I did right there. Early stopping. And you can go ahead and look at the documentation here, but to get more information, but I'll give you a quick overview here. Okay, early stopping, first of all, we need to import this, and this is pretty much, again, part of our Keras.callbacks. Okay, so I'm going to call this early stopping, okay? And I'm going to assign this to, again, a variable called early stop. And what are we monitoring here? Again, validation loss. And my patience equals to 3. Again, there are many things that you can describe. And the patience means it's the number of epochs with no improvement after which training will be stopped. What does that mean? It monitors this validation loss and then finds the minimum, right? This is the validation loss, and finds the minimum in validation loss and doesn't stop right there. And it goes 3 epochs after that just to confirm that this is exactly the lowest point, right? So you don't want this to stop while the loss is still decreasing. So that's what this early stop basically means. And let's actually add one more and then continue. So I would like to, let me copy and paste the code from my other screen. I put this in a notepad, so there it is. CSV logger. I find this to be useful. Let me, again, the way we use it is call it out of our Keras.callback, CSV logger. What does it do? Well, you know from the name, it's CSV logger. So it actually creates a CSV file of all the logs. What are the logs? It's the epoch number, accuracy, loss, or train accuracy, training loss, validation accuracy, and validation loss. Just imagine having a CSV file and then you can go ahead and plot it later on. Okay, so we are calculating this, but we need to supply all of these callbacks to our model.fit. Well, I'm using fit generator because I'm using a train generator dataset, but for you, it can be model.fit. Okay, so what are we going to provide? I'm going to provide checkpoint. I'm going to provide early stop. And I'm also going to provide log CSV as my callbacks. And everything else is, it can stay. So let's go ahead and run this one more time. Okay, so we're only doing 5 epochs. So early stopping with a patience of 3 doesn't make much sense in this case, but hopefully you got the point. But let's have a look at mylogs.csv. So if I go back, we should see mylogs.csv. I do not have Microsoft Excel to show that to you. I could have used pandas to load it, but let's just go ahead and use our notepad to have a quick look at it. You see, epochs, accuracy loss, accuracy loss, validation accuracy, and validation loss. So now you can go ahead and plot these. In the next tutorial, I'm going to show you how to evaluate the model and how to plot, but here you go. You already have enough information right here. Okay, so I hope you found this tutorial to be useful. And again, please watch the next tutorial and go ahead and subscribe to this channel so you can get all of these content delivered directly, or at least you get notified whenever I upload or update my content. So thank you very much again. Let's meet in the next tutorial.